Hi, ladies and gentlemen. Welcome to our next video. And in this case, you are thinking, if there was law of sines, is there a law of cosines? And the answer is yes. So let's now take a look at this triangle. All right, we triangle ABC, and where BC is 5, AC is 6, and the measure of angle C is 30 degrees. What is the measure of AB? So let us draw this, shall we? So here, let's see now. So in this case, AC is 6, so this is C. I'll make this AAC, and his base BC is here. So BC is 5, AC is 6, and the measure angle C is 30 degrees. And so our technique in trying to find the measure of AB, this side here, we would normally use law of sines. So let's set this up, shall we? All right, so it would be, in this case, we'll call this little c, because opposite of angle C. And so we have, well, okay, so let's take a look. The sine of A, because over A, equals the sine of C over C. And so the sine of A, well, in this case, we don't know the angle, but we do know side opposite A is 5. And the sine of C, well, we know the angle is 30 degrees, so the sine of 30 over, wait, C, well, okay, we have two different variables. Let's try a different one. Okay, let's try sine of B over B is equal to the sine of C over C. We have to use C because it's the angle measure. So, all right, so we have in this case the sine of B. I don't know how to measure angle B, but I do know the side opposite, it's going to be 6. And then we have the sine of C is 30 degrees, so sine of 30 degrees over, oh, wait, we don't have that either, so we're stuck. So now comes the big question. You know, how are we going to find this? We can't use law of sines. And a lot of it has to be with the fact we said before that law of sines, you need the angle measure and to know the measure side opposite. Here we have an angle measure, but we don't know side opposite for angle C. We have the side opposite of angle A, but we do not know the measure of angle A. And we have the side opposite of angle B, we do not know the measure of angle B. So now we're stuck. All right, and so here, this is more of a, if we take a look here, it's just kind of like a side angle side situation. In law of sines, we use a side angle or angle side situation. We can figure out the measure, but here it doesn't work out. We don't have it. So we have a new rule, and the new second rule we have is called the law of cosines. Okay, and so law of cosines. It kind of looks like Pythagorean theorem. At least you look at the first part. Is c squared equals a squared plus b squared minus 2, but then you have the minus 2ab cosine c. Or, now, maybe it's not the side c. Maybe it's a squared, side a. So a squared equals b squared plus c squared minus 2bc cosine of a. And then if we're looking for side opposite angle B, b squared is equal to a squared plus c squared minus 2ac cosine of b. So we're noticing in this case, we see that if we are trying to find angle C, then it looks like we're using a squared and b squared and then 2ab, and of course the angle opposite. So we're still trying to find side opposite angle C. So try to find side opposite angle C. We're using the sides A and B minus 2ab and then cosine of C. And the same thing here. If I'm trying to find the measure of the side opposite of angle A, it's a squared by itself and cosine of A. And here we have the other two sides, B and C both being squared. And then finally, for the last one, if we're looking for side opposite B, we're squaring that, but then using the cosine of angle B. And here, we're squaring a squared and c squared. Really, if we're given, and this is a big deal, okay, the big deal here, if we're given two sides and angle included between the sides, and if that's not screaming side angle side, I don't know what is. We will use the law of cosines to find the missing side. Okay, so it is for a side angle side situation. If I know two sides and the angle between or angle included, we can find the side opposites of the angle we have. So let's try this out, shall we? So we have in this case triangle ABC, and A is 4, C is 6, and the cosine of B is 1/16. You want to find B. So again, you can draw a triangle, angle A, angle B, angle C. Here's a little b, here's a little a, and there's a little c. And so that's 6. This is going to be 4. And I know the angle measure, well, I don't know the angle measure, but I knew cosine of b is 1/16. So we're looking for, in this situation, the measure of b, this here. So we use our formula, b squared equals a squared plus c squared minus 2ac cosine of b. And so b squared is equal to, now a is 4, so that's 4 squared, and c is 6, that's 6 squared, minus 2 times 4 times 6 times the cosine of 1/16, the cosine of b is 1/16. Well, so you got b squared, that's equal to 16, and that's equal to 36. Now, if in this situation we have 2 times 4 times 6 divided by 16. Well, me personally, I do the division and simplify right away. So we're going to simplify the 4 and the 16 to get a 4 here. And the 2 divides out here, so we get a 2. And this divides out here once, and this we get 3. So I get, in this case, 16 plus 36 plus, I left over with, I guess, minus 3 actually. Minus 3, that's a minus 3 there. Which means b squared is equal to, so that's going to be 52 minus 3 is equal to 49. Well, I'll take the square of both sides. B is equal to 7. Okay, so I just plug into my formula and I get my value. So I know in this case the B value must be 7 units. Well, let's try another one. Okay. So triangle RST, R is 11, S is equal to 2, and measure angle T is 120 degrees. So I'll draw this way here, make angle T bigger, okay? And so not drawing the scale, unfortunately. So here's angle T, which is 120 degrees. And here is, so in this case, so here's RST, so here's R, and this S, again, not drawing the scale, so I apologize if it looks weird. Little r is opposite of angle R, so here's little r, that's 11, and little s is opposite of angle S, so that's here's 2. So we're looking for the measure of T. So T squared is equal to S squared plus R squared, or R squared plus S squared, minus 2RS cosine of angle T. So here we got T squared is equal to 2 squared plus 11 squared minus 2 times 11 cosine of 120. Now, this is actual work. Filling in the values into your formula is actual work. And so here on a calculator, which I will now pull up, all right, we're going to plug this in. All right, so I believe it was 2 squared. So we have 2 squared plus 11 squared, minus 2 times 2 times 11 times cosine of 120 degrees. Now, before I hit enter, I'm going to double check and make sure that I got this set up in degree mode, and it is. Okay, totally good. So now I hit enter. I get 147. All right, so now I'm going to take the square root of 147. So second x squared, so square root. Now I can type in 147, all right, 147. And here, to the nearest integer, I'm going to get, in this case, 12.12435563, which means in this case, so here, t squared was equal to 147, to the square root of both sides. So technically t squared really, so t, not t squared, sorry, t t here is equal to the square root of 147. So, which I think in this case, if we simplify this, I can divide that by 3. It gives me 40. Oh, can I? No. Well, 147, not 149. So, divided by 3, I think I get, let's see, wow, 40. 49. Well, man, we could simplify out. But here's the thing, okay? The thing is that I really am not looking to simplify. I'm looking for the nearest integer, okay? And we said in this case, the nearest integer would be 12, okay? So that's our answer to work for. So yeah, you could simplify it. If it says near to exact value, then I definitely recommend you simplify the radical or square root of 147. All right? So 147, not 149. Okay? All right. So now we have seen in this case, well, how do we use this? How do we find our missing side? If we have a side angle side situation, we're going to, in this case, be able to use our law of cosines, okay, to find our missing side. So if we know two sides and the angle in between them, or angle included, of a triangle, we can then find the third side of the triangle. And after finding the third side, you know, if that being the case, we can then find all the other pieces as well too. Okay, so that covers the side here. So these are the first part of the law of cosines. All right. So in the second part, we'll figure out, well, what happens when we have all sides? But that's next video. All right, ladies and gentlemen, if you found this video helpful, please give it a like, leave all comments and questions in the comment section below. And you just want to, comment if you liked it, not, or if you think I could improve or something, please leave your comments. I appreciate them. Again, please hit the subscribe button and turn on notifications so that you will know, for notifications all, so you will know when I release new videos for trigonometry or any other topics on geometry or calculus or whatever math topics that I'm teaching this year or in upcoming years. And also, in any case, if you have a topic to recommend, you can recommend a topic as well too, and I would not mind going over that for you as well too. Thank you so much for watching, and appreciate your any of your comments and all. Please take care of yourselves and be safe.